Now we've repositioned the workpiece, it's on the pillar drill this time. We'll just finish off, go through those holes that we started off on the mill and get some threads tapped into them. Now all I did on the mill was just go into probably about halfway, something like that. And just finish off on here. To each one, we'll do the I'll start them off with a spiral flute tap. Plenty of lubrication. Don't go using hand taps and cheap Chinese taps for this sort of job, especially in steel. Nice, good quality spiral flute tap. In this case we've got a HSSE. See that? Europa tool. Good quality tap. And get ready to stop the drill once it's started. In fact, you could even knock the power off. We need to start it. Take her up and get a tap handle on that and finish it off. After starting them off, what I'll do is finish them off by hand. Don't want to risk a broken tap at this stage. One day I'll get an auto reverse tapping head. Till then, so to not ruin the workpiece. Nice thing with a spiral flute tap, you just keep going straight down. The cuttings, swarf comes out nice and easy, like using a drill. And you know you've got it nice and square. Nice new tap, looks lovely. Don't be afraid to throw away your blunt taps and dies, or reuse them for another purpose, but don't keep using them. Buy new ones. They're cutting tools after all, and occasionally they do wear out. Like, clean up, get set up for the next part. Do just a light deburring on the underside. That a hand countersink be sufficient for that one. Before that one's come through on the edge there, I'll have to just do a short threaded bolt. Always make a mistake somewhere, forgot to allow for that, but had I been too close to the edge, I suppose I could have gone right over there to the edge, but it'll be fine with just a short bolt. There's enough thread on it to get that. So I'll clean this off now, and we'll get some Loctite ready, and we'll bolt the two parts together, see what we've got. And slightly shorten the Allen screws just to stop them sticking through from the other side, and put a little spot of thread lock on each one. Don't want the Allen screw coming out in the planer. That would be disastrous for the cutters. Just get them all assembled before we'll do the final tightening. And one short one to clear that milled out pocket. Okay, tighten them up, see what it looks like. All in, all nice and tight, double check. Yep. Coming through on the back, that one's flush. Lovely. That's starting to look the part. Just dress that end off at the end, just to get it level. Set up for these ones next. Transfer punches, very useful, simple tool for transferring bolt holes through. It's a through hole like this. Simply get one that's a nice fit in the thread, and give it a tap. I like to use a copper hammer on punches and drifts, just so you don't damage the end. No need really. Just use a copper hammer. It fits in there nicely. We should have some nicely established punch marks. Just a little technique I'll show that I like to use to establish the hole from the centre punch mark from the transfer punches we've just tapped through there. Credit to Mr. Pete 222 Tubal Cane for this one in part, amongst others. Small drill press, small drill, and just let it find its own centre. The drill will just bend. Itself. Let the workpiece float about. Until we've got our drill holes established. You see that little bit? Yeah. That's it. Good use for a little cheap drill press to get the hole started. Now they're in there, and I'll say everything else will follow them from now on. So now we'll move over to the bigger pillar drill and get the tapping sizes in ready for the M10 on the smaller holes. 4.2mm tapping drill for M5 holes for the indicator coming in. And again we're on hand taps, not machine taps here, so just adopt a slightly different method. Let's do turning the drill chuck by hand, get it started, a little bit of pressure on once you've got it engaged there. And finish by hand again. And that actually fits on, it fits nicely for the little indicator. It fits on the reverse side of there. Yep, it's okay. So that's the transfer punch method of transferring holes. Fairly successful. We'll do a few other methods along the way. I think for the next block to be bolted on to that side, we'll use the digital readout for the whole location, just to show some different ways of doing the same job. Morning, it's another day. I'll carry on today. So far so good with the first part of this job. It fits in the block. I might have to do a couple of little tweaks because the material I'm using is imperial, not metric, so I'm a little bit thinner there, but I don't think it'll affect it. We'll have a look when it gets fitted to the machine again. I'll carry on, start cutting some more pieces up, ready for the next stage. Cold this morning. Oh. Cut the next pieces out, do them both at the same time. So we've just got to be in the other part of the workshop, so it's a little bit warmer. set up here for cutting a very shallow angle on the middle piece. There's an extra bolt securing the fence down that the piece is clamped to with a G-clamp. Just about see it around about there. Otherwise this fence, that moving jaw of the vice, wags about, so make sure everything's bolted up right, look nice and tight. And after a little bit of dressing on the linisher, will do. Our other pieces are laid out now. Let's mark off where they're going to be positioned, ready for drilling and tapping for fitting these other pieces. Nice scribed line down each of them, in line with the piece we're working from. Oops. That's it. What I probably will do for that milled out slot there, I'll probably take the bulk of it out by another method, drilling, cutting, and to minimise the amount of milling I need to do. I'm set back up on the mill again here. This time slightly different method, we'll try something else. It's the workpiece is raised away from the mill bed by a couple of little bits of packing, so I should be able to drill through completely this time. Again, set the depth stop so I don't hit the mill table. When it's drilled through, I'll tap in place, and I'll use the digital readout this time, just as a different method, another example. We're located at the edge of our workpiece. Same method as previously, using the edge finder. So we're going to move over with the table over 9mm as before, which will put us in the centre of where the threaded holes need to be, in that direction. Oops, shot a bit. Right. Fine. That's it. Lock the table at that axis, on that point on the y-axis. For this one, this time we'll spot with a centre drill. Back with a spotting drill, but we've got a centre drill, so. Just into the tip of the drill bit, that's all we need. That's enough. Swap over to the 5mm drill now and go through the two pieces. get rid of that stringy one. Like them ones. That's it. I'm just keeping my eye on the quill axis readout. Around about 20mm we should start breaking through. I'll set the depth stop up, ready for the next holes. Around about 15mm now, with 5mm to go. Then countersink as before. I've just moved the table up by 4 rotations of the hand wheel to give the correct depth for the countersink to go. And after you've done your spot with your digital readout, it's always wise to just quick check with your rule or scale, yeah, that you're in the right sort of area. So another countersink drilled and another little dimple, quick check there, yep, in the region. One point to note, I do like to use a rule with where metric's one side and imperial's the other, not the ones with combined the two systems on one side. You always find you need to be measuring both sides of the rule in the same unit, or I do, so I find these ones a lot easier. That's everything done for that operation. On that piece we've got a hose right the way through ready for tapping, so I'll remove the top piece, take the countersink out first, it's out the way. Remove our top bar. And tool maker's clamps. For a little bit of a push off, get rid of the bulk. So that piece can be taken over to the pillar drill, and them holes just run through for clearance for the M6 bolts. And we can work on this one for tapping. Again, using the digital readout, better relocate the holes accurately. We know our distance from the edge and from each side. Set up for that one next. I'll just run a 6mm drill through the top piece to give us the clearance for the bolts to go through. Easy enough to centre on them holes. Same as before, a little bit of Loctite, or your favourite thread lock. Another one on. But the same again for the other end. I'll rejoin when I set up for milling out the slot on the end piece.